as many to date, we've got to incubate. So we have a lot of different equipment we can use to help us keep things hot or cold. So incubations is this fancy word where we keep things at a certain temperature. Sometimes we also control things like the CO2 and the humidity, especially when working with like mammalian cells. And we have various ways in order to do this depending on how big our samples are, what temperature we need, do we need shaking, do we need stirring, all those various things. So this is just a guide to some of the equipment you might find in a lab for these purposes and when you might use what. But first of all, the most common temperature you incubate things at is actually doesn't require anything at all. Room temperature. So sometimes we abbreviate this as RT, and I say temperature, but it's really like temperature because like the room temperature, it totally depends on what room you are. Like there are some rooms in here that are just like really warm, and so if it's a cold day, you might want to go in there. There are other rooms that are really, really chilly. Hot day, go in there. But when we're trying to control our sample temperature, not so good. So a lot of times you'll see protocols say room temperature, and then typically, hopefully, that means that like the reaction doesn't really care that much. But for reactions that are things like enzymes and that are trying to be at really whose rate and activity and stuff is going to depend a lot on the temperature, well then having differences in temperature can really matter. And so you might see things that say to incubate at like 20 degrees C, and you're like, well, that's like room temperature, right? Well, room temperature, remember, can vary, and so you want to actually be able to keep it at 20 C. So there are various methods that we can use in order to keep things at really specific temperatures. So let's start with this. So this is a thermal cycler. Sometimes we call these a PCR machine because, well, we typically use them for PCR where we get things hot and cold and hot and cold and hot and cold and hot and cold. And in the process of doing all that, we are making lots and lots of copies or amplifying regions of DNA. The machine is really great because it can get hot and cold really fast. We can also, though, however, just keep it really hot or keep it really cold or anywhere in between. And then we can use it as an incubator PCR strip tubes. So these are typically, the limitation here is that your samples can only be like 200 microliters or so, which is really, really small. So we have other devices, though, that we can use if we have purposes of needing other devices. But these small reaction tubes can come in really handy for a variety of different purposes, various reactions that we may be doing, as well as for if we have a lot of gel samples we need to like heat up. And so like boil before we use them for a reaction. And so that can be good for that. Something that sounds kind of like a thermal cycler, but is actually pretty different, is a thermal shaker or thermal mixer. So basically these are just like these blocks, and they have, often they have different removable blocks, or sometimes you have to like screw them in and out, which is less than ideal. Sometimes they snap in and out, which is really ideal, and sometimes you can't change them. But these blocks will have holes for different size tubes, and so commonly you'll see ones for like typical eppendorf tubes, which are about like 1.8 mils, and what these do, but you can also see like plate ones and PCR tube ones and things like that. These are basically blocks that are on top of a heat controlled orbital shaker, and so they'll shake. You can also turn off the shaker if you don't want shaking, but with these really common use that we use these for is for like bacterial recovery and outgrowths after like a transformation. So with the transformation, we can stick a piece of DNA, typically like a circular plasmid, containing some gene we want bacteria to express for us, so get them to make a protein, say. And we can take that plasmid, we can stick it into bacteria in this process called transformation, often with like a heat shock step, which we'll talk about what we can use for the heat shock in a minute. But basically, you can actually use this for a heat shock too. But basically, afterwards, you need to let the cells recover in the absence of antibiotic before you then plate them on plates that have antibiotic that you're using to select for the plasmid and blah, blah, blah. But basically, you need to allow them to outgrow a little, like half an hour, depends on the antibiotic. But basically, you let them recover in these little tubes in like a mil of media, so in their food and like a shaking. And so we often do this on one of the shaker blocks. These shaker blocks are also really good for a variety of other purposes when we might need to be incubating at a certain temperature, when we have either reactions that are bigger than a PCR tube, or we need something that's shaking. And so those thermal shakers are really great for that. Highly, highly love them. Or that was supposed to be recommend, but I really do love them. Anyway, okay, you might also see something that looks like, sometimes they have like a refrigerated units, and then they can get down typically to, I think, about 0 degrees Celsius, but more often we're using them when we're trying to get things hot, or at least like keep things at a kind of near room temperature or whatever, but a more defined temperature. The thermal shaker was great if we only have those little 1 ml tubes. But once we're scaling up the cell culture in suspension cells where you have cells growing in liquid, then we need something that is going to allow us to, well, incubate bigger volumes and still shake them. And so we get these shaker incubators. They come in different sizes. So some of them are small. They have like racks, and often these are removable racks. So you can put in racks for, say, 5 ml tubes, 50 ml tubes, or big flasks. And then they'll shake and incubate. And some of these actually have also control the CO2 and the humidity, which you need when you're working with mammalian cells, which are pickier. And so they look similar, but these are going to also have this extra features. And sometimes you are growing cells that don't need to be shaken. So those petri dishes that you plated, or if you're doing like mammalian tissues that's on adherent cells, so the cells are actually stuck to the dish. In these cases, you don't need the shaking. And so we just have these like plate incubators, which are basically just these chambers with shelves, and then you put your plates on them. And if you're putting petri dishes, put them upside down so that condensation that forms on the lid doesn't like drop down onto your sample. But anyway, so you have the plate incubators, and then you have the shaker incubators, and you can have them, both kinds can be with or without the control of the CO2 and humidity, which you need for mammalian cells, but you don't need in turn when you're just working with bacterial cells. And often we're doing like 37 degrees Celsius. For insect cells, however, you might be doing more like 18 degrees, 20 degrees, depends on the cell line. But when we're working with just like bacteria or normal mammalian cells, this is typically done at like 37 degrees Celsius. And if you're doing mammalian cell culture, you're typically working around 5 to 8% CO2. Like a thermal shaker, but it doesn't shake. Basically, we just have like these heat blocks. Some of these fancy dancy newer ones are actually like digital, which is nice, because I'm guessing that they probably keep the temperature a little better. But then we also have just like heat blocks that basically just look something like a metal block that is in like a tub of sand. And that you have like a knob that you're trying to dial to a correct temperature, and then you have a thermometer in the sand and you're trying to like wiggle things, and then there's like pieces of tape that say like go here if you want this, and then go here if you want this, but then like the thermometer is like not agreeing. Yeah. It can be a mess. But this can be really good if all you need to do is like boil a sample for a gel. And so the heat blocks are really great for that. And if you can get them to the temperature you want, then they work well for the other purposes. What's really great about both the thermal shaker and the heat blocks and the PCR machine and all this stuff is that they actually have like the whole thing around the tube is heating up. And so you should get a more consistent heating. Another way to get a consistent heating of something is to surround it in liquid. So to surround it in water. And now we move on to water baths. And so water baths is just what it sounds like. It's a bath, but instead of like getting hot because you're putting hot water in it, it gets hot because you are like warming up the outside of the container. And these are really helpful if your tubes are big, so bigger than can fit in one of those thermal shakers. If your samples are like irregularly sized, maybe you want to stick a bottle of media, so bacteria or like for like cell food in there, and then you have these big bottles, well, that's not going to fit in one of those like thermal blocks. And so these water baths are really, really great for this. It's also really great if you have samples. If you have samples you want to take in and out really quick, and so we often use them for things like doing that heat shock step, where we need to take samples, put them into the warm environment for like 42 seconds, and then take them out, or 45 seconds, and take them out really quick. And so we can use either like one of these flotation devices. These, I'm not trying to advertise for Gold Bio or whatever, but you'll often see these as swag by bio companies. But you can put tubes in them and it'll float, or you can get like some sort of plastic thing like this. And basically what this is gonna do is now you can stick all your tubes and you can take them in and out as one, which is nice. Sometimes the thermal shaker blocks also have like a plastic thing on top where you can pull things in and out, but I've had trouble like them not pulling very well. But anyway, these work well. So when you have a water bath or that sort of thing, you can use one of these to kind of take things in and out really fast. You might also see like bead baths, which are like alternatives to water baths, and instead of water they have these metal beads. You see these a lot in cell culture rooms, like tissue culture rooms, your TC room. They're easier to keep sterile than water, and so you might often see those in tissue culture rooms to thaw cell stocks, to thaw to warm up the media, the food, the cells, food, and that sort of thing. Okay, So now we talked about baths and tubes and all this stuff. Let's move on to heated plates, heat plates. These like magnetic stir plates, sometimes they have heaters too. And so basically these stir plates, they have like a magnet underneath that spins, or inside, whatever, but under the plate. Then you put a magnet into your sample, and then you turn the spin on and it spins, and then you mix up your liquid. Really, really helpful. So sometimes these have a heater too, and then they'll, well, heat your samples. And this is really good if you're trying to dissolve something that doesn't really want to dissolve, maybe, or if you're trying to do some sort of like chemistry reaction type of thing where you need to keep things stirring at a constant temperature. It's harder to actually determine the temperature because your temperature is like on the plate, and then you have your liquid, which is going to have a slightly different temperature. But anyway, it's good for heating things up. But you need to make sure that you're not heating things up if you don't want to be heating things up. So make sure that the heat knob, it can get easily get like knocked. And so make sure that you don't knock it if you don't want it on. Sometimes you might want to even just like stick a piece of tape on it. I did that at my old lab. What actually happened was that never put something on the hot plate even if it's off. For storage, or if you're gonna go walk away and do something. Basically, this thing started a fire. It was not me. But there was a fire that started at my old lab because there was something left on a hot plate. So be really, really careful with that. That aside, these plates can be really, really helpful. And so don't be scared of them, just use them responsibly. And make sure that if you do want to use the hot part, that you're actually using one of the plates that has the hot heated element, because a lot of them don't, and they look pretty much the same, except that one will have 2 dials and one will just have 1 dial. So if you're planning on using a hot plate, make sure it really is a hot plate. Okay, there's a few other things that will get things hot, not really for like incubating, but they will get things hot. One of these, a Bunsen burner. My dad, I think he constantly thinks I constantly work with Bunsen burners because that's what you see in all those stock scientist photos. I don't really use them that much, but basically there's things where you have a striker, like a flint striker, and you go pew, and you turn on the gas line and then it makes flame. And often the most common thing I use them for is when I want to maintain a sterile environment, maybe when I'm like pouring LB agar plates, so those petri dishes with bacteria food. Some people use them more for depending on your field and that sort of thing, but sorry Dad, I don't really use them that much. We also, a way to get things hot is going to be a microwave, and actually we often use the microwave when we're trying to melt the solidified LB agar, that like gel that we're going to pour in our plates. If we made it ahead of time and now it's solidified, we can melt it back up and then pour it into the plates. And so the microwave is helpful for this. It's also helpful if you're trying to do some sort of gel destaining, or you're trying to speed up the process with a little short burst of the microwave. I don't know how I forgot this, but the most common thing we typically using the microwave for is when we're actually melting agarose to run an agarose gel. So little spurts to get it boiling, get that agarose dissolved. But again, with the microwave, we're not getting like exact temperatures and that sort of thing where we're controlling, and we're just doing it for a short time. It's not like an incubation, but we are getting things warm. Another time we get things really, really, really warm is in an autoclave. So this is one of these like steam sterilizers that gets things to really, really high pressures and really, really high temperatures in order to sterilize things such as our LB agar that we then let solidify if we're not using it right away, and then we microwave it so we can pour plates, and then we use the Bunsen burner to keep a sterile environment around our plates. So we use all these different things to heat things up depending on our purposes and all that stuff. Okay, so now we are going to move on to when we want to get things cool. So most common thing, ice. We can have wet ice, so just like normal ice, as well as dry ice. So that solid carbon dioxide, and more dry ice in a post from my Halloween related post on how you can do fun stuff with it. But in the lab we can use it because it's going to keep things really, really cold. So it might not seem like there's that much of a difference between your wet ice, your normal ice, and your dry ice, but the dry ice is really, really, really cold. Like we can use it to ship samples and keep them at like minus 80 degrees Celsius, because this dry ice is going to be at about minus 80 degrees Celsius, which is super duper duper cold. So if you put a sample on dry ice, do not expect it's just like putting a sample on your regular ice, and your liquids that you expect would still be a liquid if you put them on ice might become a solid pretty quick. So be careful if that's not what you want. But dry ice is really, really great if you do want things really, really cold. And if you are shipping things, you can ship in like a styrofoam container of dry ice. Now when it comes to the wet ice, often labs typically have, like in the hallways, like a shared ice dispenser, and if it gets hot in the summer, sometimes you see it gets really, really low. But we then make sure you're not that person that leaves the scoop in the ice. Don't be that person. People always do. But anyway, we can then put the ice in whatever containers we want. So most commonly you'll see a bucket like this. I really like, if you get a say, I really like the rectangular ones. These are really helpful in order to kind of lay things out better, I found, especially if you want to use some sort of really, really cool thing, like one of these cool blocks that I'll get to in a second, but it'll fit really nicely in one of these. If you have a really, really large like samples you need, like cell culture bottles, maybe you're doing an induction or you're harvesting your cells and you need the bottles to be at, you need to take these giant like culture flasks and stick them on ice. They make like giant rectangle ones, or if you don't have one of those, you can just use like an autoclave tray, fill it up with ice, and voila, you've got a large surface area of ice to work with. Now when you're just working with little tubes in ice, what can happen is those tubes can get lost in the ice, especially if you are trying to like pour out the water from the ice and put in fresh ice. You can lose tubes. I've found so many tubes in the past, and I've been sometimes my own in the sink because they go out with the ice. And then also when you're trying to like cap the tubes in the ice, then they can like get pushed in. Yeah, it's a mess. So you want some way to hold your tube steady. And one of the things, I didn't even know about these until I got here, but they make these cool racks, which are these metal blocks, and they come in different sizes with different size holes depending on your tube size. They even make ones for like 50 ml tubes, and these are really, really helpful because they'll get cold really quickly and they actually stay cold, so you can then take them out, pour out your ice, get fresh ice, or you can take them out and go put them in the fridge or something and they'll stay cold. And they keep your tubes like actually in a place, which is super duper duper helpful when you're trying to keep things organized and keep track of what goes where, rather than trying to line them all up in one of these. You can also like cap things and uncap these really quick. I'm not trying to sell a product. I do not work for this company. There's probably multiple companies that make them, but they're really, really helpful. Unfortunately, they're also really expensive, which is, so you can see, I'm not going to pay by these companies. But anyway, they make cheaper things. You can use one of these things like I was talking about. We could use these for the heat bath. We can also use these for our ice in order to line up the samples. You can also like 3D print them or laser etch them and that sort of thing as well. You can also use those, are helpful if you want to like freeze things in liquid nitrogen, which, speaking of liquid nitrogen, we can get things really, really cold with liquid nitrogen. And so you'll see liquid nitrogen, we often use this for flash freezing or snap freezing. Basically, we get samples really cold, really, really fast. This is going to prevent ice from forming, which could mess up our samples. It can also mess up the concentrations of things within the sample as ice is forming, where basically the water molecules are linking up together and they're excluding everything else. So then the concentrations of everything else gets all messed up in the other parts, and the concentration in the water part is just water. And that's not good. The ice crystals can also, if they're forming in the inside of your protein, then they mess up with protein. So basically there's problems that can come if things freeze, if water freezes when you're trying to just like freeze everything consistently. And so we can snap freeze, and liquid nitrogen is really, really helpful for that. Liquid nitrogen is good for long-term storage. You'll see these either giant dewars or smaller dewars or transfer dewars, things like this, where you can actually pour out of and take a little bit out of the giant tank in order to use. And then we have these giant dewars with like racks, and in those we often use these for storing cell stocks. So we like racks with boxes, and then in each of those boxes they'll have little tubes full of cells and that sort of thing. We can also use dewars to ship like crystals, like X-ray crystallography, various things like that. So liquid nitrogen is another thing that we can use to keep things cold, but typically that's more for like storage than actually like incubating things. Okay, now we are on to things that look more like what you would see in a house. Refrigerators, and also freezers. So refrigerators, typically you might see these referred to as like keep things at 4C. That's a refrigerator. These are about 4 degrees Celsius. So you can see it's slightly above the freezing point of water, so we're not freezing things, but we're just keeping them nice and cold. And we also have freezers, so your normal freezer is going to be about minus 20 degrees Celsius. If you see minus 20, that's just one of those normal freezers. You see minus 80, well, now that's one of our special freezers, which gets really, really cold. So remember minus 80, that was about the temperature of the carbon dioxide, the CO2, solid CO2, aka dry ice. And so this is a common temperature at which we store things like proteins. These minus 80 freezers are typically really big. Our other freezers and refrigerators you'll find in a variety of sizes, and these are just typical, like the same ones you would have in your house. So we have the small ones like under the bench, we have the bigger ones. For fridges, we also have deli fridges, and these have sliding doors, which is nice, and you can see things, and we often use these if we have big pieces of equipment. Things like protein purification machines, like Actas, which are these big machines, and we need to keep them cold often when we're doing a protein purification, so we can stick them in one of these deli fridges. And this is really nice because it avoids you having to use the cold room. And so the cold room is basically just like a walk-in fridge. Really, really cold, really, really hate working in it, but it's really great if you're doing like a gravity flow purification, something where things need to be cold and you need to be able to work with them. And it's also really useful if you need to do things that need shaking or like mutating or rolling or stuff like that. So there are various ways in which we can keep samples like agitated while we are working. So we talked about how the thermal shakers can shake things. When we're trying to do things cold, we can stick them in the cold room, but we have to put some sort of shaker on them, under them, or them in a shaker or something. So we have like orbital platforms, which are going to go. We have mutators, which kind of go like. We have end over end rollers. We have like hot dog rollers and the ones you stick your tubes actually into. So various ways of mixing the samples and keeping them rotating or shaking or that sort of thing. Often we're doing this if we're doing like an antibody incubation overnight in the cold room. We want the liquid to keep moving, so we can stick them on one of these orbital trays or that sort of thing in order to make sure that all the liquid's moving around, everything gets in contact with it. Not really incubating, but if you need to centrifuge, so spin tubes really, really fast and keep them cold, we have centrifuges. Some of them have like refrigerated, and so you'll see typically an R at the end of the name for refrigerated. So they often have versions that are refrigerated and non-refrigerated, and the refrigerated one will have the R at the end. These will keep things cold, but they take a while to actually get cold, especially the bigger ones. So if you're wanting to use it cold, make sure you turn it on ahead of time and press like the fast temp button. Make sure there's nothing in there, or else it's going to slow things down or potentially give you an imbalance error if someone left just the balance tube in there or something. Then just press the fast temp and it'll cool itself off, and make sure that the temperature is set to where you want it before you press fast temp, so it actually goes to the right temperature that you want. And in terms of like for ultra centrifuges or even just the normal centrifuges, we typically keep the rotors in the in the fridge, and this is going to keep them cold so that you only need to warm up the device and you don't have to worry about the rotor being hot. And so your samples will be cold right away, even if you didn't do that fast temp. I think that was pretty much it. So we have a variety of lab equipment that we can use for different purposes. What your purpose is going to dictate what you're using, as well as what's available is going to dictate what you're using. And yeah, just have fun experimenting and don't be intimidated by all the different equipment. It's all there to help. And remember that room temperature, who really knows?